Hey everyone, my name is Mukul and welcome back to NIIT Presents LangChain by Project series. And today we're building something extremely useful and honestly something I wish every developer had in their toolkit. We're creating a resume versus job description match analyzer powered entirely by LangChain LCEL, Llama 3 and Streamlit, all running completely locally through Ollama. This tool takes a resume and job description, analyzes both of them, and finds matching skills, missing skills, and then calculates a match score of it. And then generates a full career report in one clean pipeline. And the best part is, we're not just writing code for the sake of it. We're using a LangChain expression language to build a smooth, multi step workflow that actually feels like a real production system. It's clean, it's modular, and it's honestly a joy to work with. So, yeah, we've got a lot of cool stuff lined up. Let's get into it. Alright, before we jump into the code, let me quickly show you how this entire project works behind the scenes. Think of it as a simple 3-layer system. Layer 1 is the input layer. This is where the user brings in two things: a resume, either pasted or uploaded as a PDF, and a job description. That's it. Just these two pieces of text. Now from there, both of these inputs move into layer 2, which is the processing layer. This is where our pedantic models start doing the heavy lifting. The model extracts all the important structured information from both the resume and the JD, things like the summary, technical skills, tools and frameworks, soft skills, and domains. So basically, it turns unstructured text into clean, machine readable data. Once that's done, everything flows into layer 3, which is the output layer. Here we compare the extracted skills, calculate the match percentage, identify strengths, highlight the gaps, and finally generate a complete career report with actionable recommendations. So it's a very clean flow. Input, processing, final report. It's simple, modular, and easy to understand, and the code follows this exact same structure. Alright, so now that you understand the flow of the project, let's finally jump into the code and go through it. I don't want this to feel like a boring documentation walkthrough. I want you to actually feel the logic behind each part. So let's get into it. Right at the top, we start with all our imports. Nothing fancy here, just the essentials we need. We pull in typing helpers, Streamlit for the UI, Pydantic so we can define structured output, and PyPDF so the user can upload their resume as a PDF. Then we grab all the LangChain pieces, Chat or Llama, to talk to our local Llama 3 model, the prompt template system, the output parsers, and the LCL runnables. Think of this whole block as us laying the table before we start cooking. Everything we need later comes from here. Then we set one simple variable, the model name. We're using Llama 3.1 that tells Ollama, hey, use this model for every AI call you make in this app. Now comes something important, the Pydantic model. We define a class called profile analysis, and this is basically the shape of the data we want from the LLM. So instead of the model giving us random paragraphs, we force it to produce a clean summary, a list of technical skills, tools and frameworks, soft skills, and domain knowledge, each as proper lists. This is the secret behind getting structured, reliable output instead of the LLM just dumping text. Then we initialize the LLM itself using Chat or Llama. We set the temperature super low, like 0.2, because we want accuracy and consistency, not creativity. We also attach the Pydantic parser and grab the format instructions, which is basically a cheat sheet, and the LLM needs to generate perfect JSON output. So up to this point, we've basically wired the LLM brain and told it exactly how we want it to think and respond. Now we move into the good stuff, like the analysis chain. This is the part where we actually extract useful information from the resume and the job description. We build a prompt that tells the model you're about to analyze either a resume or a JD. Be precise, don't hallucinate, and return only valid JSON using the structure we gave you. Then in the human message, we pass in the raw text. But here's where things get really nice. We pipe this prompt into the LM and then directly into the Pydantic parser. So the output of this whole chain is literally a clean profile analysis object. No post-processing, no cleanup, just pure structured data. But this project needs two analyses, one for the resume and one for the JD. Instead of repeating code or running them one after the other, we use LCEL's runnable parallel, and this thing is magic. Inside it, we create two branches. One branch knows it should analyze the resume. The other branch knows it's handling the JD. Both grab the right text, attach the same format instructions, and run through the same analysis chain. And because it's parallel, both analyses happen at the same time. Clean, simple, and now you give LCL two inputs, and you get two beautifully structured outputs. One for the resume and one for the job description. Next comes the logic brain of the app, the scoring system. First, we define a small helper that cleans and normalizes skill lists. It trims lower cases, removes duplicates, just making everything tidy so comparisons are fair. Then we jump into the main scoring function. And here's what it does. It pulls the structured resume data and the structured JD data, and then for each category, technical skills, tools, soft skills, and domains, it compares what the JD wants versus what the resume has. It calculates the overlap, the missing parts, and then generate a percentage score for each category. But we don't stop there, because some skills matter more than others. So we apply weights. Technical skills matter most, then tools, then soft skills, and domains matter the least. After applying these weights, we combine everything into one final match score. And that number, that's what the user sees as the big percentage on the screen. We wrap this scoring function inside a runnable lambda so that it becomes just another step in our LCL pipeline. Now comes the final AI layer, the explanation and career advice. This is where we act like a hiring manager. We build a prompt that says, look at the structured analysis and the scores. Explain in 3 to 5 bullet points why the candidate got the score, strengths, gaps, all of that. And then, depending on whether the overall match is less than 60 or more than 60, give either improvement steps or interview questions. So if the candidate doesn't fit the role, well, we give them a list of things they should work on. If they do fit the role, we prepare them for interviews with targeted questions and short prep tips. The LLM runs this prompt, formats everything in clean markdown, and we attach the entire report back into our result dictionary. Now that we have the analysis step, the scoring step, and the report generation step, we can finally build the full pipeline, and it's literally just online. Analysis, chain 2, scoring runnable, and report runnable. 3 steps, one end-to-end system. You give it resume text and JD text, and it gives you a complete career match report. After that, we add a tiny utility function to extract text from uploaded PDFs. Nothing fancy, just loop through each page and gather all the text into one string. This lets people upload their resume instead of copy-pasting it. Finally, we build the Streamlit user interface. We set the page title, create 2 columns, resume on the left, JD on the right, and let the user either upload a PDF or paste text. When they click Analyze Match, we validate the inputs and then run the entire AI pipeline with a single dot invoke call. Once the results come back, we show the overall match percentage, where break down matched versus missing skills, print category scores, and finally display the complete hiring manager style report generated by Llama 3. So now, after reviewing whole code, let's go open the terminal and write the command to run the script, which is streamlit run your project name.p and enter. This is the interface of our app. Resume JD match a simple, clean layout. Exactly what we need for this kind of tool. On the left side, we have the option to upload a resume as a PDF. I will upload a sample resume here, and as soon as the file is processed, the resume text is extracted and placed neatly into the text box. No extra steps, no complicated formatting. It just gets the text and puts it right there. On the right side, we have the job description text area. I'm going to paste in a JD I found online, just a standard one you'd normally see on LinkedIn or Naukri. You don't need to edit or clean anything. just paste it as it is. Now that both of these are filled in, I'm going to click Analyze Match. You'll see the Streamlit spinner appear. And while that's running, the entire LCEL pipeline is working behind the scenes. It's analyzing the resume and the JD in parallel, extracting structured information, comparing every skill category, running the scoring logic, and finally generating the explanation with Llama 3. All of that is happening right now in a single smooth AI workflow. And once it's done, we get our results. Right here at the top, we can see the match result, giving us a quick understanding of how well the resume aligns with the JD. Then as we scroll down, we reach the skill match breakdown. This section is extremely useful because it shows you very clearly which technical skills matched, which ones were missing, what tools the JD expects, what soft skills are required, and what domain keywords were found or not found. And at the bottom, we have the explanation and action plan. This is generated by Llama 3 based on the comparison. It explains the reasoning behind the alignment, highlights strengths, highlights gaps, and then gives a practical improvement plan. And that's the full workflow, from running the app, uploading your resume, pasting a job description, to getting a detailed breakdown and a personalized report. Everything works locally and structured in a way that feels genuinely helpful. And that wraps up today's episode of the LangChain by Project series. In this episode, we didn't just build another demo. We built a complete end-to-end resume JD match analyzer that works exactly like a real production tool. We used LangChain's expression language to structure the entire workflow. We extracted clean data from both the resume and the JD. We compared skills, generated a detailed breakdown, and even created a personalized career report, all running locally on Llama 3. If you have followed the code along with me, you now understand how LCEL can help you design clean, modular pipelines without writing unnecessary boilerplate. And if you're building your own AI-powered tools, this pattern is something you can reuse again and again. If you found this episode helpful, feel free to leave your questions or thoughts in the comments. And if you're enjoying this series and want to learn more about LangChain, Llama 3, and building practical Gen AI projects, make sure to subscribe so you don't miss the next one. Thank you for watching, and I'll see you in next one.